good in terms of changing these into slope-intercept form, okay? The reason they need to be in slope-intercept form is because we need to graph them, right? So let's take the first one, for example, which was 2y plus 6x equals 3. Did anyone change that into slope-intercept form successfully? And can tell me how you did it. Emma, go for it.
I subtracted 6x from both sides.
Excellent. So once you subtract 6x, what do you get?
I get 2y equals negative 6x plus 3.
Love it.
And then I divided both sides by 2. And then I got y equals negative 3x plus 3 over 2.
Excellent. How many people got to this step for the first equation? Good, okay? Now, the one thing that we ran into issues was how do you put 3 over 2 as a y-intercept? Does anyone know how to do that? Grayson?
You change it to a mixed number, it's 1 1/2.
Very good. This is the same. 3 over 2 is the same as 1 1/2 or 1.5, right? Where is 1.5 on the y-axis? In the middle of 1 and 2. So you should have put a y-axis intersection at 1 1/2, between 1 and 2. Now, what is the slope of that red equation? Negative 3. Camilla, how can you use the slope to draw the line?
You go down 3 to the right 1.
Down 3 to the right 1. So let's move down 3 units. 1, 2, 3, and then to the right 1. Go down 3, 1, 2, 3, and then to the right 1. And we've got a nice line. It's not perfect, but it's okay, okay? I'm going to do the second equation in a different color. I'm going to do it in blue. Who was able to change the second equation into slope-intercept form? Diana?
My iPad turned off. Hold on.
Oh,
It's, do I say the answer? Or do I do this?
explain how you got it. Yep.
Okay. So you subtract 3x to both sides.
There we go.
And then it gives you y equals negative 3x plus 2.
Perfect. Negative 3x plus 2. And how do you graph that, Diana?
You put 2 since it's the y-intercept.
Mm-hmm.
And then you go down 3 to the right 1.
1, 2, 3 to the right 1. 1, 2, 3 to the right 1. So it has a slope of negative 3, and its intercept is at 2. Guys, look at these graphs closely. If you did it correctly, are these lines ever going to intersect each other? No. Why not? Zoe? They're parallel. Guys, what makes two lines parallel? Camilla? They have the same slope. What is the slope for both of these lines, Grayson? Negative 3. Do you guys see that negative 3? If you have the same slope, they're never going to intersect. And remember, the solution to a system of equations is where they intersect. If they never intersect, how many solutions do we have? 0. Okay? If they don't intersect, there's no solution. The answer is 0. There's no solution to this system of equations. Cool, right? Okay? Now, what if they were the exact same line? They intersected everywhere. How many solutions do you think we would have? Emma? Infinitely many. Okay? There can never be 2 solutions. That will never be your answer. It can either have 1, 0, or infinitely many. Cool beans? All right. Now, the only way that we've learned how to do these problems where we have 2 equations, right, with x and y, is to graph them and find out where they intersect. Do you guys agree? Today, we're learning we can do these problems without even using graph paper. We don't have to graph them at all, okay? The first method that we're going to learn, and you guys should highlight this, is called substitution, okay? And the best way for me to teach you guys substitution is just by doing a bunch of examples, okay? You're kind of going to learn it on the fly, okay? It's something that you pick up as the more examples that you do. So, for this first example, I want you guys to jump down to example 1, letter A, okay? In this example, it says y equals negative 2x minus 9 and 6x minus 5y equals negative 9. I'm sorry, negative 19, okay? In this example, I want you guys to look at both of the equations and ask yourself, are either of the equations solved for one of the variables? Is one of the variables automatically by itself on one side of the equation? Sabrina? Absolutely. It's y in the very first equation. So what we do is we box that in. We box in the y equals negative 2x minus 9. And you need to highlight the right side of the equation. Highlight the negative 2x minus 9. This becomes what we're going to call our substitution, okay? This substitution, what we're going to do is we're going to say, okay, if y is negative 2x plus minus 9, take this part, the right-hand side of your substitution, and put it in for wherever you see y in the other equation, okay? So we're using both equations. This one's our substitution, and we're plugging in this gray part into our second equation, okay? So let's rewrite the second equation, which was 6x minus 5y equals negative 19. 6x minus 5y equals negative 19. And wherever we had y, erase it. So erase your y. And instead, what are we going to put in replace of y? Not 0. Negative 2x minus 9. Because look, isn't y the same as negative 2x minus 9? In order for both of these to be true, we can substitute in this negative 2x minus 9 for the y in the second equation, okay? So erase the y, and in parentheses, put negative 2x minus 9. You might have to move some things around to space it out, but this is what it should look like. What is no longer in the red equation? What don't you see anymore? Sabrina? The y. It's all in terms of x, right? Can we solve this red equation? We sure can. Could we solve either of the ones above? No, because they had two variables, right? There was x and there was y. Now we can solve for x. Who knows how we would go about solving for x in this red equation? Emma, what would you do? Very good. Distribute first. What would you get after you distribute? 6x plus 10x plus 45 equals negative 19. Beautiful. From here, what could we do? Eli? Yeah, move over the 45. I like it. So subtract 45. Subtract 45. Who's good with those negatives? What am I going to get there? Negative 64. And on the left side? Sabrina? Y. Very good. But why?
Oh, because you have to, because they're both like terms.
Combine like terms. I love it. Even though the vocab. 16x is on the left. And my last step, peeps, to solve for x. Darius? Divide by what?
16.
Excellent. Divide by 16. Once we divide by 16, what am I going to get? Zoe? Not 4.
What?
Negative 4.
Negative.
Negative 4. Very good. Okay? All right. So, but think back, guys. When we were solving these, when they were graphed, right? They would intersect. What was our solution to a system of equations? What was our solution? Hold on. What was our solution? Yeah. It was a point. Right now we just found x. What else do we need? We need y, okay? So right now in our point, we know that it's negative 4. Do we know what y is? No, so we have to figure out what y is. Any ideas on how we could solve for y? Sabrina?
You interject negative 4 for the x.
There she is. You just take that negative 4 and you can plug it into either of the original equations, whichever one you want, okay? Which one do you think would be easier, the first one or the second one? I would say the first one. So let's use the first one. Let's say y equals negative 2x minus 9. That's the original equation, the very first one. Instead of x, what do I plug in? Negative 4, okay? Take this negative 4 and plug it in there. So it's y equals negative 2 times negative 4 minus 9. What's that going to give me, guys? Sabrina?
That's going to give you 8 minus 9.
8 minus 9, which is
Negative.
-1. So my final answer is what? Sabrina? -4, comma -1. Did I have to graph a single thing? No. Could I have graphed it and gotten the same answer? Absolutely, okay? But substitution is like graphings for schmucks, okay? We can do all of these questions by just substituting it, okay? Now, on your quiz, there's going to be questions that say you have to solve this by graphing. There's going to be questions that say you have to solve this by substitution. I'm going to be looking for the method that you used, okay? So you need to know, we're going to learn one more method after this one, but you need to know the difference between all of them. Got it? So if you're solving by substitution, should you be graphing? No, okay? If you're solving by graphing, should you be using substitution? No, unless you're using it to check your answer, that's the only reason you should use it. Rachel, what's up? All right, let's do another one. Let's do B. In B, again, first things first, we're looking for if either of the equations have a variable that's already solved for. Do they have a variable that's already solved for? Sabrina? Yeah. Does it matter which one we pick? No, they're actually both solved for y. So let's go ahead and let's just pick the first one, just to be convenient, okay? Highlight the right side of the first equation, 3x plus 14. That is now our substitution. We're going to take the second equation and replace what variable? We're going to take the second equation and replace what variable? Diana?
Y.
Y. Very good. What are we replacing it with?
3x plus 14.
Our substitution, 3x plus 14. So rewrite the second equation, which was y equals -4x. Replace your y, so erase the y, and instead put 3x plus 14. You guys with me? And that's a 15, not a 14. All right, from here, we have an equation only in terms of x. Can we solve it? We sure can. What would you do, Zoe? Love it. Let's subtract 3x from both sides. What do you get after that step, Zoe?
-7x.
Very good. 14 equals -7x. Who can help me solve it as the last step? Cooper? Very good. How'd you get that? Yep, divide -7 to both sides, and you get -2 equals x. We're done? No, we only have half of our answer. How do we get the other half, Sabrina? You plug it in. Which one did you plug it in for?
You have to plug it into the because isn't that the 1? Oh, no.
Yeah, we're trying to find y. Does it matter which one we plug it in for? No, because it's the solution to the whole system, we'll get the same answer regardless of which one we plug it in. So I usually just pick the easier one. And I would say the bottom one's easier, right? Y equals -4x. So let's just pick the bottom one. So we're going to write y equals -4x. And instead of x, I replace it with -2. So y equals -4 times -2, which is -8. Oh, not -8. +8. So who wants to take a shot at the final answer? Various? -2, 8. Very good. Remember, when you have a system of equations, your solution is not x equals this, y equals this. It's going to be a point. It's going to be a coordinate, okay? C is challenging. I'll give you guys the option. Do you want to do C? It's going to have fractions. Do you want to do it together, or do you want to try it on your own? Try it on your own? Okay, work in your groups and try C on your own, okay? Work on your groups and try C on your own. See if you guys can get it. Sorry, my charging team back there. Try C. For the most part, we're pretty good about picking the right equation for substitution. Which one of these two, the top or the bottom, should we have picked for substitution? Rachel? The bottom one. Very good. Why the bottom one, Rachel? Very good. It's already, y is already solved for, okay? We don't need to do any extra steps. So my substitution now becomes 1/2 x minus 1. Tavarius, are we substituting that in for x or for y?
For y.
How do you know it's for y?
Because y equals 1/2.
Exactly. It says y equals, okay? So we're going to take that bottom part and we're going to substitute it in to the top equation, okay? So now we've got 3x plus 2. Instead of 2y, it's going to be 2 times 1/2 x minus 1 equals 0. How many people got to this part? Raise your hands. Good, okay? From here, how do I go about solving this? Sabrina? Excellent. What do I get?
You would get 3x plus 1 plus x.
Mm-hmm.
No, you don't have to put the 1.
Correct. I don't have to put the 1.
Minus 2.
Minus 2.
Equals 0.
Beautiful. From here, Emma?
You add 3x and x.
Yep. So I got 4x minus 2 equals 0. What else, Emma?
And then you you add 2 to both
Mm-hmm.
sides.
Good. Keep going.
And then you get 4x equals 2.
Yep.
You divide 4x from both sides.
Divide by 4. Perfect. So we get x equals 2 over 4 would be wrong. Why? It's not simplified. What does it simplify to, Camilla? 1 over 2. How many people got x equals 1/2? Okay? Good. Now, the next part, I don't know why I threw some people off. Okay? When we plug it back in, I would have plugged it into the bottom equation just because it's a little bit simpler. We're going to get y equals 1 over 2 times 1 over 2 minus 1. What is 1/2 times 1/2, peeps? Eli? 1/4. Y equals 1 over 4 minus 1. This is not 0. Emma? What's 1 as a fraction? 1 over 1. Good.
And then you have to multiply 1 over 1 by, the top and the bottom by 4. So you can
Excellent. Why are we doing this?
subtract, so you can subtract it.
Yeah, but what do you need before you can subtract fractions? Zoe?
The same denominator.
A common denominator. Very good. Okay? So we multiply by 4, we get y equals 1 over 4 minus 4 over 4. And Emma, what do I get when I do this? Negative 3 over 4. Emma got like super close, like 9 different times, and then finally she pulled through. Okay, so my final answer is not this though. What's my final answer? My final answer. Davon? 1/2 comma negative 3 over 4. Beautiful. Are we Gucci on that one? Okay. Now, letter D is a little bit different. Okay? Why is D a little bit different? What's different about D? Zoe? Very good. None of them are solved for y. Is one of the equations solved for another variable though? Zoe? Very good. The first one is solved for x. Do you guys see that? So this is going to be our substitution. And the right side of our equation becomes highlighted. So now I'm going to plug in 6y minus 7 for what? For x. Okay? So rewrite this second equation as 4 times 6y minus 7 plus y equals negative 3. Do we see the difference there? Now we're substituting for x because x becomes our substitution. Okay? Do we see that or should I explain it again? Be honest, guys. Should I go over it one more time? All right, I'll go over it one more time. Guys, look. Do you see how in the other problems it was y equals something in terms of x? In this problem, it's x equals 6y minus 7. So this becomes my substitution. So I plug in this y, 6y minus 7, where I see x in the second equation, okay? So I rewrote 4x plus y became 4 times 6y minus 7, because x is now 6y minus 7, plus y equals negative 3, okay? So we're substituting the same exact thing, but we're substituting for a different variable. Now, do you see how x disappears, and we no longer have x in the blue equation? Now we can go ahead and solve. How would you guys solve the blue equation? Distribute, very good. What do I get when I distribute to various?
24y minus 28 plus y equals negative 3.
Excellent. 24y minus 28 plus y equals negative 3. What would we do from here, guys? Zoe? Excellent. Add 24y and y. What do you get? 25y minus 28 equals negative 3. Next step. Emma? Add 28. Beautiful. We're going to get 25y equals what? 25. And my last step, peeps. Divide by 25. So y equals 25 divided by 25 is? Uno. Am I done? No, why not? Camilla? Very good. I have to find x, right? Because my answer is going to be a coordinate. And right now, I only have the second part of my coordinate. I only have the y value. So I need to plug back in y to find x. So let's just write, I'm going to use the first equation. X equals 6y minus 7. Plug in y equals 1. X equals 6 times 1 minus 7. This is going to be x equals 6 minus 7. So x should be equal to negative 1. So your answer is negative 1 comma 1. Yes. Which 25?
The 25y.
Okay, so the 25y came, when we distributed, you said that we got 24y minus 28 plus y, right?
Yeah.
Remember, like terms are 24y and y. Y technically has a 1 in front of it. Do you agree?
Yeah.
So 24 plus that 1y will give me 25y.
Oh, okay.
Do you see it now? And then the minus 28 stays, and then we just add 28 to move everything over to the other side. Okay? Good question. Any other questions on D? We're Gucci? Okay. What do we do when a variable isn't solved for? Let's check out the next slide, people. Okay? Example 2 says solve the system of linear equations by substitution. Look at letter A. Are either of my equations solved for a variable? No. They have x and y both on both sides. So all we need to do is one quick, easy step. Okay? Take the first equation and rewrite it as negative x plus y equals 3. So write it the exact same way. How can we solve that equation for either variable? Sabrina?
Y equals x plus 3.
Very good. What did you do?
I just added x to both sides.
Excellent. Just add x to both sides. Once we add x to both sides, we get y equals 3 plus x. Is this solved for a variable? Yeah, it's solved for y. Do you see how y is by itself now? So the right side of my equation becomes my substitution, the 3 plus x. What do I do with the 3 plus x now? I put it into what? The other equation, okay? You plug it into the other equation. So we're going to take 3x plus y equals negative 1. And wherever I see y, I'm plugging in 3 plus x. So I'm going to do 3x plus, instead of y, I'm substituting in 3 plus x equals negative 1. Did I lose you guys? Or are we okay? I'm seeing some blank stares. What do I do from here? Zoe?
Add 3x, 2x,
Why?
because they both have like terms.
Very good. They're like terms. So what do I get when it's 3x plus x?
4x
4x plus 3
is negative.
equals negative 1. What would I do next? Camilla?
Subtract 3 from both sides.
Love it. Subtract 3 from both sides. We're going to get 4x equals negative 4. Last step, peeps. Divide by 4. X equals negative uno. We done? No siree. Pick either equation that you want. I'm going to pick the first one and plug that sucker back in, okay? Negative x plus y equals 3. Take the negative 1 and plug it into the original, okay? So we've got negative 1 plus y equals 3. What should I do here? Emma?
Change the negative 1 to a positive 1
Very good. Why?
because two negatives cancel out.
Excellent. A negative times a negative is going to give me a positive, so this will be 1 plus y equals 3. And last step, Emma?
You subtract the 1 from both sides. Oh, and you get y equals 2.
Beautiful. Final answer, Zoe.
I have a question.
Before the question, what's my final answer?
Negative 1, comma 2.
Negative 1, comma 2. Yeah, what's your question?
For the second part, why wouldn't you plug it in so y equals 3 plus x?
You could do that too.
Oh.
Yep. So Zoe was asking, why don't we plug in the negative 1 to y equals 3 plus x? You can plug it in there, okay? My recommendation is plug it into one of the originals. Because the originals we haven't touched, right? So if you haven't touched it, it should be good, like a good equation. If you messed up somewhere, okay, and you plugged it into maybe this one, okay, you may get the wrong answer. So I would just plug it into one of the originals that were given to you, okay? It's also a way to check, did I copy down the question correctly, okay? All right, we're going to jump down to D, okay? So take a look at D. Are either of the equations completely solved for? No. So we've got to pick one and solve it ourselves. What do you think we should do in D? Sabrina?
Subtract 3x from both sides on the lower equation.
So you're picking the bottom one? I love it. Okay, let's pick the bottom one. We've got 3x minus y equals 1. And you said subtract 3x from both sides? Love it. Subtract 3x, subtract 3x. What do you get?
You would get negative y equals negative 3x plus 1.
Love it.
And you can cancel the negative.
Good. Divide everything by a negative 1 to cancel out that negative. What do I get?
Y equals 3x plus 1.
No.
No. Y equals 3x minus 1.
Minus 1. Is this solved for a variable? Sure is. Do you see how y is by itself? So now 3x minus 1 becomes my substitution. Where do I plug that in? Into y for which equation? Sabrina? The top one, okay? You have to use both equations. So we use the second one for our substitution. We have to use the first one now to solve it. So we have 2x minus, instead of y, I need to put 3x minus 1 equals negative 5. We're going to write 2x. What do I get when it's minus outside the parentheses? Grayson?
Distribute the negative in both.
Good. So it's going to be minus 3x plus 1 equals negative 5. From here, what should I do? Camilla?
Combine like terms,
Excellent. What are the like terms?
2x and negative 3x,
Okay, what do you get?
negative 1x, negative x,
Good. So negative x.
plus 1 equals negative 5.
Uh-huh.
And then you subtract 1 to both sides.
Yep.
And then you get negative x equals negative 6. And you divide negative 1 to both sides to pick up the negative.
Yep.
And you get x equals 6.
Perfect. So x equals 6. From here, what do I do? Grayson?
Plug in plug in the 6 for the equation.
Very good. Which one would you pick?
Can you do the one that we already solved, the y equals 3x minus 1?
Yes, you can. We can use y equals 3x minus 1. So let's take y equals 3 times 6 minus 1. What do you get? Yep.
18, so 17.
Perfect. Yep. What's my final answer, Joseph?
It is going to be 6 times 17.
Yep. How are we feeling? Is this okay? Are we intimidated? Okay. We're feeling all right? Okay. The last thing that I want to go over is I want to do one word problem, okay? So, scroll all the way down. Yes, I know it's our favorite, okay? Scroll down to example 3, okay? I broke it down into 3 steps. You need to define your variables, we need to create 2 equations, and then use substitution to solve them, okay? A drama club earns 1,040 from a production. A total of 64 adult tickets and 132 student tickets are sold. An adult ticket costs twice as much as a student ticket. Write a system of linear equations that represents this situation. What is the price of each type of ticket? Okay? Identify what your variables are. Okay? So write down on your page X and write down on your page Y. We need to figure out, okay, there's got to be 2 things that we need to find or that we don't know. What are they? And what are the 2 things that we're trying to find? Zoe? Very good. The price of each type of ticket. So let's say X is the price. What's one type of ticket? The price of an adult ticket. If X is the price of an adult, what would Y be? What's the other thing that we need to find? Diana?
Student?
The price of a student. Okay? Now, it says write a system of linear equations. So we need to have 2 equations. Does anyone think they can come up with the equation, the first equation? Camilla? Very good. You're on the right track.
You have to like multiply 64 times 2 because an adult ticket is twice as much as a student ticket.
Don't combine them, okay? They're gonna be separate equations. But let's take what you started. So can someone help Camilla out? She said 64, which is the number of adult tickets, times the price of the adult, plus what? Sabrina?
132
Good.
equals 1,040.
Excellent. So 64 tickets, right, for adults, times the price of the adults will give you the amount of money you earn from the adults. Do you guys agree? Plus, how many student tickets were sold? 132. You multiply that by the price of the student tickets, and that will give you the total amount that you made, right? Perfect. So this works. What is the second equation going to be? And it has to do with this statement. Only 2 other students have gotten this so far today. Emma, you want to take a shot?
Is it x equals 2y?
Excellent. X equals 2y. How did you get that?
Because it says the adult ticket costs us twice as much, so you could do, since y is the price of the student, that times 2.
Very good. Y is the price of a student. Do you guys agree? So if you have y, you multiply it by 2, that'll give you the price of an adult ticket, because it says an adult ticket costs twice as much as a student ticket. Okay? Now, let's use substitution. Are either of these 2 equations completely solved for? They are. Which one? The second one. X equals 2y. So, box it in there. And 2y becomes my substitution. I'm going to sub in 2y for what? The first equation for what? For x, okay? So we're going to write 64, whoops. We're going to write 64 times 2y plus 132y equals 1,040. Oh, yeah. Okay, from here, what's 64 times 2, peeps? 128y plus 132y equals 1,040. Now, someone with really good addition skills. What is 128 plus 132? Eli? Hey, 260. So 260y equals 1,040. We would just divide both sides by 260. And honestly, guys, it's a matter of trial and error. Just try a bunch of numbers to multiply by 260. You'll get y equals 4. The bell's going to ring. Turn this in the way that it is, okay? I don't know why the bells are ringing so early. And then we will finish. All right, and then once we have y equals 4, we just take that and we plug it in. We already know that the price of the adult ticket is twice the value or the price of the student ticket. So we just take that 4, we plug it into that second equation that we have because it's much simpler. And we're going to get x equals 2 times 4, which then gives us x equals 8. So we have our x value, we have our y value. That means that the price of each ticket, the student tickets are student tickets are $4 and the adult tickets are $8. And we're done. All right, those are all the notes that I have for today. As your exit ticket, I would like you to solve that system of equations by both substitution and by graphing. It's a great way to check yourself and make sure that you're doing it the same way. It also makes a strong connection between the 2 forms of solving systems of equations.